Welcome to the Special Forces in World War II podcast, transmitting on this frequency. This broadcast is your dedicated channel for comprehensive intelligence regarding World War II Special Forces operations. Our transmissions encompass in-depth analysis of their strategic maneuvers, cutting-edge equipment, illustrious biographies, and an array of pertinent subjects. The orchestration of these transmissions is executed by the expert team of the Special Forces in World War II website, a squad deeply immersed in the historical theatre. For further insights, visual aids, and captured moments frozen in time, navigate to our virtual headquarters at worldwar2-soft.com. Your immersion into the front lines of knowledge awaits. Over and out. Welcome back to another episode of the Special Forces in World War II podcast, where we dive into the bold, the daring, and the extraordinary stories, tactics, and equipment of the special and specialized forces whose actions helped shape the outcome of World War II. I'm your host, Michael Wires, and as always, we're here to uncover the lesser-known stories behind the remarkable units whose courage and innovation redefined the battlefield. In the early hours of May 10th, 1940, something entirely new lands on the roof of Fort Eben-Emael. Not paratroopers, not bombers, not tanks, silent gliders. In a matter of minutes, one of Europe's most modern fortresses is shocked into paralysis, and the world is forced to confront a new reality. Airborne warfare is no longer theory. It is now a weapon. This episode tells the story of the DFS 230, the German assault glider that makes those landings possible. It begins long before the first troops ever climb aboard. It begins in the years when gliding is quietly turned into a national program, when engineers at the Deutsche Forschungsanstalt für Segelflug begin designing aircraft that are not meant for sport, but for surprise attack. It follows the men who push the idea forward, including Hans Jacobs, Kurt Student, Ernst Udet, and Hans Jeschonek, and the test pilots who prove that a glider can land a squad exactly where no aircraft should be able to land. We trace how the DFS 230 is built, how it is flown, and how it evolves under combat pressure. We look at the braking parachutes, the rocket systems, the training schools, and the brutal reality of one-way landings where recovery is never expected. We follow the glider into every theater where German airborne forces operate, from Belgium and Crete to North Africa, the Eastern Front, and the mountains of Italy. Because the DFS 230 is not just an aircraft, it is a delivery system for shock and surprise. It is the silent machine that turns a fortress roof into a landing zone, a mountain plateau into a battlefield, and a frozen lake into a supply runway. And in the process, it becomes one of the most distinctive weapons of the Second World War.
It's tax season, and at LifeLock, we know you're tired of numbers. But here's a big one you need to hear. Billions. That's the amount of money in refunds the IRS has flagged for possible identity fraud. Now here's another big number. 100 million. That's how many data points LifeLock monitors every second. If your identity is stolen, we'll fix it guaranteed. One last big number. Save up to 40% your first year. Visit lifelock.com/podcast for the threats you can't control. Terms apply.
So, let's start at the beginning.
In 1922, Hermann Goering holds a private conversation with American Captain Edward Eddie Rickenbacker, the celebrated First World War fighter ace. Goering tells him that Germany's future will be decided in the air. Air power, he says, will be the means by which German strength is restored. He lays out a three-stage plan. First, Germany will teach gliding as a sport to its young men. Second, it will build up commercial aviation. Third, it will create the framework of a military air force. When the moment is right, Göring predicts, all three strands will be brought together and Germany will be reborn.
Göring proves to be right. Gliding subsequently becomes an important element of German rearmament. It provides a means to train thousands of glider pilots from whom the Luftwaffe later draws many of its future aircrew. Between 1930 and 1933, new directions emerge in German glider development. A decision is taken to design a larger sport glider intended to carry a meteorological laboratory, with scientists and technicians operating instruments during flight.
The design and development of this unusual aircraft take place at the Rhön-Rossitten Research Institute in Munich. The project involves leading German specialists, including the well-known engineer and glider designer Alexander Lippisch. It brings together expertise from both the sport glider world and the broader aircraft industry. By 1933, the work produces a completely new type of aircraft that breaks with established sport glider design. The new machine has a much larger fuselage intended to carry heavy loads. Its wings are strengthened to support additional weight. The long, elegant wings typical of sport gliders are replaced by shorter, thicker ones. The resulting wing form resembles that of powered aircraft more than that of a sailplane. In appearance, the aircraft looks like a transport aeroplane without an engine. After takeoff, it must be towed by a powered aircraft, then released within gliding distance of its landing area, descending steadily to the ground. As a rule, it cannot maintain altitude by exploiting air currents like a true sport glider. Its weight and design commit it to a continuous descent, leaving little scope for soaring. When lightly loaded, however, many pilots report that it handles much like a conventional glider. Under favorable conditions, some manage to exploit air currents and achieve brief periods of soaring.
For high-altitude meteorological work, the aircraft proves ideal. In free flight, it is silent, free from vibration, and free from the electrical emissions common to powered aircraft, which can interfere with sensitive instruments. The aircraft becomes known as the Flying Observatory, and Hanna Reich tows it during the early test flights. General Ernst Udet inspects the Flying Meteorological Observatory and immediately sees possible military uses. He believes it could supply encircled units and even imagines it as a modern Trojan horse, landing soldiers unseen behind enemy lines. Udet is not alone. Other forward-thinking Luftwaffe officers share his interest, and General Hans Jeschonek, in particular, presses for the development of a combat version. From the outset, the project is given a secret classification and handed over to the Deutsche Forschungsanstalt für Segelflug, which is affiliated with the Rhön Research Institute. Aircraft engineer Hans Jacobs, the chief engineer of the Deutsche Forschungsanstalt für Segelflug, assumes responsibility for the program. He is assisted by experienced glider pilots on the staff and begins the work of transforming the concept into a viable military aircraft. By the mid-1930s, advocates of airborne warfare within the Luftwaffe identify a critical limitation in parachute operations. German armed forces are experimenting extensively with parachute troops and developing airborne tactics. No one, however, has yet seen a combat glider, nor has such a weapon been tested under operational conditions. German planners identify several advantages to glider landings. A glider can carry a small, cohesive unit, delivering a squad of 7 to 9 soldiers who land together and are ready to fight immediately. Parachute drops, by contrast, scatter troops over wide areas, often 150 to 200 meters apart. Paratroopers must assemble under pressure, losing time and creating confusion. And if they are engaged while assembling, casualties can be severe. A glider lands in a confined area and allows its troops to disembark at once, without the need to disentangle themselves from parachute harnesses. Silence is another major advantage. A glider can be released several kilometers from its target and often land without being detected, a level of surprise rarely achieved by parachute operations. Officers around Oberst Kurt Student, Inspekteur of the Kommando der Flugschulen, therefore seek a different solution. They want a small assault party that arrives together, fully armed and precisely placed. A troop glider offers that solution. It approaches silently, carries an entire squad, and lands directly on or beside the objective. In 1936, this idea takes a decisive turn when Adolf Hitler watches gliders practicing takeoff and landing. During this demonstration, he asks Professor Georgi whether a glider can be built to transport troops. At this time, Georgi serves as head of the Deutsche Forschungsanstalt für Segelflug. The institute operates from Darmstadt and directs the development of gliding in Germany. Georgi passes the question to Hans Jacobs. At Darmstadt-Griesheim, the Deutsche Forschungsanstalt für Segelflug already possesses the necessary infrastructure. Wind tunnels, sailplane expertise, and experienced engineers are in place. Georgi asks whether such a troop-carrying glider can be designed and built. Jacobs states that the institute has until then only developed gliders for sporting use, which makes an immediate technical answer difficult. Jacobs is nevertheless instructed to design a glider capable of carrying 9 fully armed soldiers. It must be able to glide and dive silently, land on short and unimproved fields, and be inexpensive. The target cost is set at 7,500 Reichsmark, calculated to equal the cost of delivering 10 men by glider rather than by parachute, and to match the manufacturing cost of 10 parachutes. The Deutsche Forschungsanstalt für Segelflug naturally becomes the center for early military glider development. In practice, it functions as a discrete experimental workshop for the Luftwaffe's new concept. The project formally begins in October 1936. Jacobs recognizes a clear operational possibility. He understands that a glider towed to between 1,800 and 2,700 meters can be released. From that height, it can fly many kilometers into enemy territory. He notes that such an aircraft would remain unseen, even in early daylight. The design work is led by Hans Jacobs himself. He is supported by Heinrich Wöpel and Adolf Warner on aerodynamics, Ludwig Pieler on structural analysis, and Herbert Lück as part of the Darmstadt engineering team. By early 1937, Jacobs and his team complete a full-scale mock-up. This mock-up is significant because the glider is not an adaptation of a sports glider. It is a purpose-built military transport, designed around the size of a fully equipped infantry party and the need to land in confined, uneven terrain. In their assessment, the design can carry 9 troops, including personal weapons and operational equipment, and it demonstrates sufficient internal space and structural strength. The prototype impresses officials of the Reich Air Ministry. Following inspection, the ministry places an official order and commissions 3 experimental aircraft. These prototypes receive the designation DFS 230. During 1937, the Deutsche Forschungsanstalt für Segelflug constructs 3 flying prototypes under the designation DFS-LSS. These aircraft, completed as LSS-1 to LSS-3, mark the transition from concept to reality, and flight testing begins the same year. Hannah Reich conducts the first demonstration flight in Munich before a group of senior observers. Among them are the First World War ace von Greim, Albert Kesselring, and Erhard Milch. The flight of the DFS LSS is judged an outstanding success. Contracts are soon negotiated with the Gotha Wagon Fabrik, a railway wagon manufacturer based in Gotha. Despite the enthusiasm of several senior figures, the project does not win universal backing, and some members of the High Command worry that the program lacks direction and imagination.
Oberstleutnant Hans Jeschonek, then Chief of Operations of the Luftwaffe, summons Oberst Kurt Student to his office. The two men are long-standing friends and colleagues. Jeschonek explains the glider project and admits bluntly that no one really supports it. He tells Student that the best solution would be for him to take it under his personal supervision, warning that otherwise it will stagnate. This is Student's first clear awareness that a transport glider program exists. He is immediately intrigued and agrees to take responsibility. He flies the glider repeatedly to evaluate its performance. Student judges the design to be excellent. He finds the ratio of empty weight to payload favorable and praises its flying characteristics. From the outset, Student intends to use the glider both as a transport aircraft and as an offensive weapon. Its silence, he believes, makes it ideal for surprise attacks. With Student's backing, the aircraft enters production. Student personally names it the DFS 230 and describes it as an attack glider. Debate, nevertheless, continues. Advocates of parachute troops oppose the glider, seeing it as unwelcome competition. Sharp differences of opinion persist within the military. On May 10, 1937, the Luftwaffe takes a decisive step and authorizes construction of a first production series. Even at this stage, emphasis lies less on pure flight performance and more on tactical usefulness. Engineers and soldiers test landing accuracy, approach profiles, rollout distance, and the speed with which troops can disembark and fight. A second demonstration is organized for the Army General Staff at Stendal on November 16, 1937. 10 Junkers 52 aircraft carry paratroopers, while 10 gliders transport glider troops, each towed by an additional Junkers 52. The force flies to the airfield at Stendal. The gliders are released and dive steeply to the ground, landing close together in formation. The glider troops disembark as intact units, ready for combat. The paratroopers encounter a strong breeze and are scattered widely on landing. In some cases, they come down far from their ammunition containers, which descend separately by parachute. The trial evaluates operational factors rather than engineering theory. It measures release distance, descent control, landing precision, and assault readiness. The exercise proves that a glider can place a squad on target faster and more coherently than parachute delivery. The demonstration does not undermine the value of paratroopers, but it clearly shows that a troop-carrying glider can be a highly effective weapon. At this point, the assault glider becomes a weapon system rather than an experimental aircraft. With the concept validated, the Luftwaffe builds an institutional framework to support it. In 1937, a preparatory glider training course is established at Griesheim. 60 pilots attend under the leadership of Fritz Stamer. On April 1, 1938, the Luftwaffe forms its first dedicated command for troop and cargo glider operations at Fürstenwald. This development embeds the DFS 230 within a formal training and operational structure before the war begins. A major obstacle soon emerges. The Deutsche Forschungsanstalt für Segelflug excels at design and prototyping but lacks the capacity for mass production. Large-scale production is initiated under the supervision of the Gotha Works, with many firms involved in manufacturing. Early manufacturing begins in July 1939 at Robert Hartwig in Sonneberg, a factory better known for toy production. By June 30, 1940, 109 gliders are delivered. However, the Luftwaffe identifies a deeper issue. The original Deutsche Forschungsanstalt für Segelflug design is too complex for economical large-scale manufacture and field maintenance. To resolve this, responsibility shifts in November 1938 to Gotha Wagenfabrik. Gotha receives orders to simplify the structure without compromising performance. By the end of March 1939, Gotha completes a revised prototype, designated V5. Testing at Rechlin confirms the changes. This simplified configuration becomes the standard DFS 230A1 production model. The process follows a familiar German pattern. A research institute develops the concept, and an industrial firm refines it for serial production. Throughout development, one tactical requirement dominates all design decisions. The glider must land extremely close to the objective, within a very small area and under full control. This requirement drives several engineering solutions. Jacobs and Adolf Wanner conduct formal research into dive control brakes, producing controllable drag for steep descents. Their work supports approaches that are both sharp and precise. Later variants add braking parachutes and eventually nose-mounted braking rockets to further reduce landing distance. Weight reduction and field practicality remain constant priorities. The DFS 230 uses mixed construction, typical of German gliders. Wood and fabric components are combined with a strong fuselage structure. The interior is narrow and uncomfortable by design. Space is sacrificed for weight savings and reduced frontal area. Every aspect of the aircraft reflects its single purpose. It exists to deliver a small assault force exactly where it is needed, under conditions no powered aircraft can tolerate. The Luftwaffe establishes a dedicated glider training school at Braunschweig-Wagram. Pilots complete a 6-week course focused on operational techniques. Training emphasizes blind flying, precision navigation, and exact spot landings. Pilots repeatedly practice landing within extremely confined target zones. Exercises include steep descents and short flare-outs to a fixed touchdown point. The objective is to land directly on or immediately beside the target. Training scenarios include simulated landings on fortress roofs and restricted terrain. Operational doctrine assigns only one pilot to each DFS 230. The standard glider includes a single pilot seat, and no reserve pilot is carried during combat missions. To support instruction, dual-control trainer variants are introduced. The DFS 230A2 and later B2 allow an instructor to assume control if required. These versions are used exclusively for training and conversion. In the months before combat deployment, the DFS 230 undergoes extensive field exercises. Fully loaded gliders operate with various tow aircraft. The Luftwaffe tests multiple towing configurations and release techniques. Crews refine the timing of glider release to achieve precise, unpowered approaches. By spring 1940, Allied intelligence identifies the DFS-230 in quantity production. Reports correctly note its capacity of 1 pilot and 9 soldiers, and they also identify its intended role in surprise assault operations. The testing phase is complete, and the DFS-230 stands ready for operational use. Production expands rapidly in the years before the outbreak of war. Manufacture proceeds in secrecy between 1937 and 1939. Early construction takes place at Deutsche Forschungsanstalt für Segelflug facilities in Darmstadt. Larger-scale production soon transfers to Braunschweig to increase output. Civilian firms are subcontracted to meet rising demand. A toy factory in Thuringia produces early batches. Later production involves Gotthard Wagenfabrik, Bücher, and Erle. Operational units received their first DFS-230 gliders in early 1940. These deliveries coincide with preparations for the Western Campaign. By spring 1942, the Luftwaffe fields approximately 700 aircraft. Total production exceeds 1,477 gliders before termination in 1943. The DFS-230 is designed as a lightweight, high-wing monoplane assault glider with a strut-braced wing. It is intended for one-way combat missions where recovery after landing is not expected. Construction is therefore kept deliberately light and simple. The design prioritizes lift, controllability, and ease of production over long-term durability. The fuselage consists of a tubular steel frame covered with fabric. This structure provides adequate strength while keeping overall weight low. The troop compartment forms a narrow but rigid cabin. The wings are constructed from wood around a single main spar. They are fabric-covered with plywood reinforcement along the leading edges. The wing design uses a high aspect ratio to improve glide efficiency, giving the DFS-230 excellent gliding performance. When fully loaded, the glide ratio is approximately 8:1. When empty, it reaches between 15:1 and 18:1. This performance allows the towing aircraft to release the glider several kilometers from the target. The silent approach preserves surprise, which is critical for assault operations. In size, the DFS-230 is compact compared to later Allied gliders. The production model has a wingspan just under 22 meters and a length of approximately 11.3 meters. Wing area measures about 41 square meters. Empty weight is approximately 860 kilograms, reflecting the fabric and tube construction. Maximum takeoff weight is around 2,100 kilograms. This allows a useful load of roughly 1,200 kilograms. In operational use, the glider carries 1 pilot and 9 fully equipped infantrymen. In some cases, 8 troops are carried with additional equipment. The interior is extremely confined. Troops sit on a narrow padded bench running along the fuselage. Seating alternates between forward-facing and rear-facing positions to maximize space. The pilot sits alone in the nose section and operates with only basic flight instruments. These include an airspeed indicator, altimeter, rate of climb indicator, turn and bank indicator, and compass. Rapid exit after landing is essential. The glider therefore incorporates large openings on both sides of the troop compartment, allowing troops to exit simultaneously from both sides.
The pilot exits through a separate side-hinged canopy. Despite its simple appearance, the DFS 230 incorporates features specifically designed for assault landings. It has no conventional landing wheels. Takeoff is conducted using a jettisonable two-wheel dolly, which is released immediately after the glider becomes airborne. Landing is performed on a strong central skid, mounted beneath the fuselage. The skid is spring-loaded to absorb impact forces, allowing the glider to slide to a halt on grass, soil, or rough ground. Later models introduce braking improvements to shorten landing distance. Typical landing speed ranges between 55 and 65 kilometers per hour. This low speed allows touchdown in confined areas or even on man-made structures. Maximum towing speed ranges between 180 and 209 kilometers per hour, with structural limits dictating this range. After release, the optimal glide speed is approximately 115 kilometers per hour. Stall speed is around 56 kilometers per hour. These characteristics give pilots a wide margin for maneuver during the final approach. Armament is minimal and intended only for immediate self-defense. Early DFS 230 variants carry no weapons. Combat experience leads to the installation of a 7.92 mm machine gun on many aircraft, typically an MG-34 or MG-15. The weapon is mounted on a swivel at the starboard side of the cockpit or roof. A troop member operates it during the final approach. Fire is directed forward through a narrow opening, and accuracy is limited. Its primary function is suppressive fire during landing. Some later aircraft are fitted with twin forward-firing MG-34 machine guns mounted on the fuselage sides. These fixed guns prove unpopular due to recoil and poor accuracy. Overall, the DFS 230 sacrifices protection and heavy armament for simplicity and performance. Low weight, high lift, and precise controllability define the design. These qualities make it an effective assault glider for surprise landings under combat conditions. During its service life, the DFS 230 undergoes a series of modifications and experimental developments. Each variant seeks to improve landing precision, pilot training, or carrying capacity. These changes reflect operational experience and evolving tactical requirements. The DFS 230A1 enters service as the initial production model. It is a single-pilot assault glider with no onboard armament and no special braking equipment. This version establishes the basic dimensions, structure, and performance characteristics used by all later variants. It represents the simplest and lightest operational form of the design. To support pilot training, the DFS 230A2 is developed as a dual-control version of the A1. An additional set of flight controls is installed, and seating is arranged in tandem so an instructor can supervise a trainee pilot. Apart from the dual controls, performance and handling remain unchanged. The A2 serves exclusively in training units. Combat experience leads to the introduction of the DFS 230B1. This version incorporates a braking parachute housed in the rear fuselage. The parachute deploys on landing and creates aerodynamic drag, significantly shortening the landing run. Pilots can now fly steeper approaches and stop within confined spaces. Landing distances can be reduced to approximately 20 to 30 meters. The B1 also introduces provisions for defensive armament. A rear-facing 7.92mm MG-34 machine gun is mounted to provide limited protection during descent and immediately after landing. From 1941 onward, most combat operations employ B-series gliders equipped with parachute brakes. The DFS 230B2 combines the features of the B1 with dual flight controls. Like the A2, it serves as a training aircraft. It allows instructors to familiarize pilots with braking, parachute procedures, and armed configurations. The B2 is not intended for frontline combat use. Further refinement produces the DFS 230C1. This late production assault variant retains the tail-mounted braking parachute. It also introduces nose-mounted braking rockets. These small reverse-firing rockets activate just above the ground and sharply reduce forward speed before touchdown. With both parachute and rockets, the C1 can descend at extremely steep angles. Approaches of up to 80 degrees are possible, and the glider can come to a halt within 20 to 30 meters. This capability supports missions requiring exceptional landing precision, including mountain and rooftop landings. The C1 retains the defensive armament of the B1, and many special operations during 1943 and 1944 use this variant. The DFS 230D-1 appears as an experimental refinement of the rocket brake system. Built as prototype V6, it features an improved nose rocket design. Engineers aim to increase reliability and braking effectiveness. Only one prototype is constructed. It does not enter series production. Although technical lessons from the D1 likely influence the final C1 configuration. An attempt to increase troop capacity results in the DFS 230F1. This prototype, designated V7, features a lengthened fuselage and enlarged wing. The wingspan increases to approximately 27.6 meters. The design is intended to carry 15 troops instead of 9. Testing takes place around 1942. By this time, larger transport gliders are already available, offering greater capacity with better practicality. As a result, the F1 remains a single prototype and is not adopted. Engineers also explore more unconventional configurations. One project joins two DFS 230 fuselages side by side beneath a new central wing section. This twin fuselage glider, sometimes referred to as DFS 203, has a greatly increased wingspan of approximately 27.6 meters. It is intended to carry heavier loads or multiple squads. Wind tunnel testing reveals no significant advantage over the standard design, and the project is abandoned before operational use. An even more radical experiment produces the Fokker Achilles FA-225. In this configuration, the wings of a DFS 230 are replaced with a 3-bladed rotor derived from the FA-223 helicopter. The rotor spins freely during towing. This enables extremely steep approaches and very short landing runs, with forward speed greatly reduced. Tests show the aircraft can fly successfully. However, the low towing speed and slow approach make it highly vulnerable in combat. Only one example is built, and the concept is abandoned. German engineers propose several additional ideas using the DFS 230 platform. These include rocket-assisted takeoff, water landing variants with floats, combined aircraft towing arrangements, and experimental powered assault versions. None progress beyond testing or design studies. One of the most unusual concepts is the Mistel, a composite arrangement that fuses a DFS 230 with a conventional aircraft. One of the first combinations tested extensively in October 1942 pairs a DFS 230 with an Focke-Wulf FW-56 Stüsser. The FW-56, however, lacks sufficient engine power to take off with the composite from the ground. Instead, the combined aircraft must be lifted into the air while being towed by a Heinkel HE-111. Another configuration uses a Messerschmitt B F-109E with a DFS 230 attached underneath it. The FA-225 is also part of this broader experimentation. It is an experimental hybrid design with only a single example ever built, combining the rotor system of the FA-223 helicopter with the fuselage of a DFS-230B assault glider. The concept is intended for Fallschirmjäger insertions into areas where there is insufficient clear ground for a conventional glider landing. In a related test, a three-bladed autogyro rotor is fitted to the fuselage of a DFS-230 to examine the feasibility of a vertical landing system. In practice, the low towing speed makes the combination vulnerable. The system also requires release directly above the target area, which adds further risk. In the end, none of these experimental designs move beyond trials or design studies. In operational use, the A, B, and C series, together with their trainer variants, account for nearly all DF's 230 gliders used in combat. Each modification reflects battlefield experience and the continuing need for greater landing precision under combat conditions. Operating the DFS 230 demands precise coordination and specialized techniques in launch, towing, and landing. The glider has no engine, so every phase depends on external control and timing. Launch and tow procedures are therefore critical to mission success. Standard practice uses a long towing cable, measuring approximately 40 to 100 meters. The primary towing aircraft is the Junkers 52 three-engine transport. In combat operations, the tug usually flies without cargo to maximize available power. One Junkers Ju-52 normally tows a single DFS 230. Three Junkers 52 aircraft, each with a glider, can take off in V formation to launch a 9-glider assault force simultaneously. This method allows concentrated airborne insertion. Other aircraft types are also used as tugs when required. Twin-engine bombers, such as the Heinkel 111, serve in this role. Dive bombers and fighters are occasionally used under special conditions. During mountain operations in Italy, Junkers 87 Stuka dive bombers tow DFS 230 gliders through narrow valleys. Light reconnaissance aircraft and even single-seat fighters tow gliders during training or emergencies. A telephone wire runs along the tow cable, enabling direct communication between tug and glider pilots. It proves especially valuable during blind flying or cloud penetration. Takeoff uses a detachable wheeled dolly beneath the glider. As the tug accelerates, the DFS 230 lifts clear of the ground and the dolly drops away automatically. The glider continues the tow, supported only by its central skid. Typical towing speed ranges between 150 and 190 kilometers per hour. Junkers 52 aircraft carry a row of 8 small lights beneath the tailplane. These are mounted in a V-shaped metal hood facing rearwards. The lights are invisible from the ground, but clearly visible to the glider pilot. By keeping the lights in view, the pilot maintains correct position relative to the tow aircraft. If the lights disappear, the glider is either too high or too low. Thanks to its efficient glide performance, The DFS 230 can be released several kilometers from the objective. Crews aim to release at an altitude not exceeding 1,500 meters. Early release reduces exposure and prevents engine noise from warning the enemy. The tow cable is released either by an explosive bolt or a manual control. From that point, the glider approaches the target in complete silence. Landing accuracy represents the greatest technical challenge. The DFS 230 is fitted with hinge flaps and air brakes to control descent angle. For confined objectives, these alone are often insufficient. As said earlier, from later A-series models onward, a braking parachute is introduced. With the parachute deployed, descent angles of up to 80 degrees become possible. For extreme landing conditions, the C-series introduces nose-mounted braking rockets. These reverse-firing rockets ignite a fraction of a second before touchdown and dramatically reduce forward speed. Combined use of parachute and rockets enables landings within approximately 20 meters. These methods are hazardous but essential for missions requiring exceptional precision. Once on the ground, stopping distance remains critical. The central skid absorbs impact and allows the glider to slide to a halt. Crews sometimes modify the skid in the field. Barbed wire or improvised hooks are attached to increase ground friction, further shortening the landing run. Sudden deceleration often throws occupants forward. Troops wear padded harnesses, and internal padding reduces injury. Even so, hard landings frequently cause bruises or fractures. The glider's structure is robust enough to protect occupants in most crash landings. Many gliders strike obstacles or ground loop, yet still deliver troops or supplies successfully. After landing, operational doctrine treats the DFS 230 as expendable. Troops exit rapidly through the side doors and secure the objective. The pilot, usually a Luftwaffe non-commissioned officer, arms himself and joins the ground action. There is normally no plan to recover the glider. To deny intelligence to the enemy, crews often destroy the aircraft after unloading. This is done using demolition charges or by burning the fabric covering. In some supply missions, particularly on the Eastern Front, recovery is attempted. If a suitable landing area exists, an empty glider may be towed out by a light aircraft or hauled by ground vehicles. Such recoveries are uncommon. The primary objective remains delivery, not retrieval. By design, the DFS 230 accepts one-way use in exchange for the ability to land troops in locations otherwise unreachable. The DFS 230 sees operational service across every major theater in which German airborne forces operate. Its employment ranges from precision assault landings to hazardous supply missions. Throughout the war, the glider proves adaptable to radically different combat environments. The combat debut of the DFS 230 occurs on the Western Front, during the opening hours of the German campaign in the West. In the early morning of May 10, 1940, assault gliders land directly on the roof of Fort Eben-Emael in Belgium. The fortress guards key bridges over the Albert Canal and is considered impregnable. A special detachment of the 7th Flieger Division, led by Rudolf Witzig, employs 9 DFS 230 gliders. They carry 78 assault troops equipped with explosives and silenced weapons. The gliders are released at low altitude after being towed from many kilometers away. They descend silently and land before the defenders can react. Assault teams immediately neutralize gun turrets and strongpoints using shaped charges. Other gliders land near the canal bridges and seize them intact. After a day of internal fighting, the Belgian garrison surrenders. The Eben-Emael assault demonstrates the full potential of glider warfare. The defenders expect parachute landings and prepare accordingly. The silent rooftop landings bypass all external defenses. German losses remain minimal. The strategic effect far exceeds the size of the force involved. Military observers worldwide recognize glider assault as a new form of warfare, and other major powers rapidly begin their own glider programs. Within Germany, the success strengthens confidence in airborne forces. The DFS 230 next sees large-scale use during the invasion of Crete in May 1941. During Operation Mercure, approximately 90 gliders deploy alongside mass parachute drops. Glider-borne troops land near Maleme airfield and positions around Hania. Many land directly on or beside defended objectives. Allied forces are alert and prepared, reducing surprise. However, the gliders still deliver troops with precision. On landing, the skids raise clouds of dust on the dry terrain. This dust briefly conceals the assault teams as they disembark. German forces secure footholds near Maleme. This enables air transport landings within 24 hours. After 10 days of heavy fighting, Crete falls. German casualties are severe. The losses prompt Adolf Hitler to prohibit further large-scale airborne invasions. Crete becomes the final mass assault operation for the DFS 230. After Crete, the glider's role shifts toward transport and supply, especially in North Africa. Long distances and limited infrastructure complicate logistics. The DFS 230 delivers ammunition, fuel, and medical supplies to Forward Africa Corps units. Gliders land at night, near isolated positions without prepared airstrips. In late 1941, gliders resupply German detachments cut off in the Libyan desert. The small ground footprint of a glider makes concealment easier than a transport aircraft. Many gliders are abandoned after unloading. German planners also prepare the DFS 230 for Operation Hercules, the planned invasion of Malta in 1942. Several hundred gliders are allocated for the assault. Modifications include braking parachutes to handle rocky landing zones, and glider strips are prepared in Sicily. However, changing strategic priorities delay the operation. By November 1942, the plan is cancelled. The DFS 230 never conducts another large-scale assault in the Mediterranean. It continues transport duties in Tunisia and between Italy and North Africa until Allied advances cut supply routes. One of the most famous DFS 230 missions occurs in Italy during September 1943. Following Italy's armistice, Benito Mussolini is imprisoned at the Hotel Campo Imperatore on the Gran Sasso plateau. Adolf Hitler orders a rescue operation. On September 12th, 12 DFS 230 gliders are towed into the Apennine Mountains. Each carries a pilot and 9 troops. Conditions are extreme. Thin air, strong winds, and a tiny landing area complicate the approach. Guided by a Fieseler Storch, the gliders descend steeply and land on a narrow meadow beside the hotel. Several strike rocks or obstacles. All land without fatal casualties. Assault troops quickly overwhelm the guards. Mussolini is extracted without resistance. The mission succeeds completely. Many gliders use braking rockets to avoid overshooting the plateau. Afterward, the gliders are destroyed on sight. The operation becomes legendary, and the DFS 230 proves decisive in delivering a strike force to an otherwise inaccessible location. On the Eastern Front, the DFS 230 assumes a vital supply role. German forces often operate far from supply bases and face encirclement. The Luftwaffe forms dedicated glider supply units. Gliders deliver food, ammunition, medical supplies, and dismantled weapons. During the Demiansk Pocket, in winter 1941 to 1942, gliders land on frozen lakes and improvised fields. They supplement Junkers 52 transport aircraft. Some evacuate wounded on return tows. Similar missions occur at Kulm. These operations demonstrate the value of gliders where runways do not exist. During the Stalingrad encirclement, glider use is considered but never executed. Proposals call for heavy glider deliveries onto frozen terrain. High winds, enemy fire, and shrinking landing zones prevent implementation. Trainloads of DFS 230 gliders reach forward areas but are never deployed. The episode highlights the desperation of the situation rather than operational success. Late in the war, gliders again support besieged garrisons. During the siege of Budapest in winter 1944 to 1945, DFS 230s deliver supplies into the city. They land or crash land in parks and open spaces under fire. Many fail to reach their targets. Some succeed in delivering limited supplies. Similar missions reportedly occur at Breslau and even within Berlin during the final months of the war. Fuel shortages and Allied air dominance make powered transport difficult. Gliders provide a final, silent alternative. By the end of the war, the DFS 230 is obsolete and highly vulnerable. Despite this, it continues flying until Germany's collapse. Its operational history demonstrates both innovation and desperation. Throughout the conflict, the DFS 230 remains a unique tool for precision landing and last resort resupply under extreme conditions. The DFS 230 begins as an experiment, a simple aircraft without an engine, built from wood, fabric, and steel tube. Yet in service it becomes something far more significant. It turns silence into a weapon. It allows a small assault party to land together at the exact point where surprise matters most, and to strike before an enemy can even understand what is happening. From the roof of Fort Eben-Emael to the dust and chaos of Crete, from supply drops on frozen lakes to the high plateau of Gran Sasso, the DFS 230 proves both its value and its limitations. It is precise, daring, and brutally expendable. It is used for innovation and later for desperation. As the war turns against Germany and gliders become a last resort for isolated garrisons and collapsing fronts. By 1943, the design is already being overtaken by larger and more practical transport gliders. By 1945, it is obsolete and dangerously vulnerable. But even then, it continues flying until the very end. Its history is a reminder that in war, new technology does not always arrive as something complex or heavily armed. Sometimes it arrives as something almost fragile, something silent, and something capable of changing the battlefield in a single landing. To explore this subject further, including photographs, maps, original documents, and the full list of sources behind this episode, visit our website at worldwar2-sof.com, where you will find the dedicated pages covering the DFS 230 and the airborne operations in which it is employed. And that concludes today's episode. To explore this subject in greater depth, including photographs, maps, original documents, and the complete source list behind this series, visit our website at www.worldwar2-sof.com, where you'll find dedicated pages on Fort Eben-Emael and the Albert Canal crossings at Veldwezelt, Vroonhoven, and Canna. In preparing this episode, we once again drew on several key works that illuminate the planning, training, and execution of Germany's first large-scale glider operation. Chief among them is the Fall of Eben-Emael, the daring airborne assault that sealed the fate of France by James Mrazek. We also consulted The Fall of Eben-Emael, Belgium, 1940, Raid 38, by Chris McNabb. Alongside these, we made extensive use of Eagles of the Luftwaffe, DFS 230, by Neil Page. Together, these sources show how the DFS 230 came from an idea to operational assault and transport glider. Thank you for joining us on this episode of Special Forces in World War II. If you enjoyed the story of the DFS 230 and the rise of German assault glider warfare, be sure to subscribe, leave a review, and tune in next time as we uncover more daring operations from the world's most legendary special forces. Your support helps us continue to bring you more stories of courage, daring, and the unsung heroes of the special forces of World War II. And there is no better reminder of that than the DFS 230 itself, a fragile machine of wood, fabric, and steel tube, yet capable of landing a strike force on a fortress roof, a mountain plateau, or a frozen lake, and changing the course of a battle in a matter of minutes. Be sure to tune in next time as we dive into yet another remarkable operation that helped shape the outcome of the war. Until then, keep your wits sharp, your courage steady, and remember, sometimes the most incredible victories come in complete silence. This is Michael Wires, signing off from the Special Forces in World War II podcast. See you in the next episode.